So I suggest you all open your terminal or IDE of choice. I'm going to be using Visual Studio Code for this class. Maybe we can raise, we can get a bit of light. Okay. Too much. Okay. So there are different ways of working with Python. Who has already some experience with Python? Okay, very few people. So one way of working with Python is from a terminal. Maybe I can open a new terminal just to make it more clear. If you just type Python, you're going to open a Python interpreter. And then you can just simply write Python commands there, and they're going to be evaluated on the fly. So Python, contrary to C++, is an interpreted language. Is not a compiled language, so there is no compilation and then execution. You just send commands, they are interpreted on the fly. If they are correct, they are executed. If they are not correct, they generate an error. There is no compilation, which makes it at the same time easier and harder. It's harder because if you do stupid mistakes, you don't have a compiler that tells you before execution what kind of stupid mistakes you have made. So you're going to discover it only when you execute it. Okay, but for prototyping in general, interpreted languages like MATLAB and Python, they are considered easier because they're faster. They allow you to test things more rapidly than compiled languages. So one way I use Python is as a calculator. Instead of opening a calculator app when I need to do math, I open a Python terminal on a Python interpreter on my terminal. And then if I need to do this kind of math, I just do it there. So that's one way in which you can work with Python. However, this way of working with Python doesn't scale because everything you write there is not going to be saved. So this is only fine if you really want to do some quick test of, I don't know, 3-4 lines of code. So you don't care about saving the code. Most of the time, that's not what you want to do. So we are not going to use this modality of working with Python very much. By the way, once you're inside the terminal, to exit, you can do it either with the function quit or Control D. That's the only way to exit a Python interpreter. So if you want your code to remain after you're done writing it, you need to write it inside a file. So you can just create a file. I call my file python tutorial.py. The extension of the file should be .py. And then you can write everything you want in here and execute the file from the terminal to see the results. Like if here I create a variable x equals 3.4, and then I print the value of that variable. Now I can go in my terminal and I can simply write Python and name of the file, which is python tutorial.py, enter, and it prints 3.4. Sometimes when you execute a file, it's handy to remain inside the interpreter after the file has been executed. You can do that adding a -i in front of the file name. So you do Python -i file name, and after executing, you remain inside the interpreter, which means that you can go and check what was the value of the variable x. What if I do x plus 1? So you have the context of that script. Okay. By the way, the -i stands for interactive, because you can interact with the interpreter after the execution. Just a way to remember it. So if you want to print, there is a function print, very simple. You have parentheses, and then you can add everything you want. So if you wanted to add some context to this print, you could add a string in front of it saying x equal to, or like the variable x is equal to, and then comma x. So if I execute this, I get this more verbose print, the variable x is equal to 3.4. And you can add as many things as you want in the print. It has no limit. So you just separate things with a comma. You can have strings, you can have variables, you can have math. Instead of x, I could print 2x. It works. It's very flexible. Another very useful thing to know are comments. So you can see that here on the top, we have this text, which is colored in orange. And we have also here other text, which is colored in green. So this text here is not necessary. I could remove it and my script would work exactly the same, because that's just comments. You have two ways of writing comments in Python. So if you want to have a one-line comment, you just add the symbol sharp, one-line comment. If instead you want a multi-line comments because you want to write some long text, it's easier if you do it with this approach. You have 3 quotes. This is a multi-line comment. So anything that goes in between these two symbols is a comment. And if you use an IDE like Visual Studio Code, those are going to be colored so that it's immediate for you to understand that that's a comment. One thing you might have noticed is that there is no symbol for ending a line, contrary to most programming languages. Okay, there is no comma or colon or semicolon at the end of the line. So the way you end the line is by hitting return. So starting a new line, that's really part of the language. And so you need to be careful with that. You cannot just put together things in one line. Like if I do this, it doesn't work. In C++, this wouldn't be a problem because you typically have a symbol there for ending the line. But in Python, you don't. And so if you put 2 instructions in the same line, that's an error. So in this case, Visual Studio Code tells me that that's an error. But if you're not using an IDE, well, you're going to get a runtime error. So when you execute the script, the interpreter is going to tell you syntax error, invalid syntax. Okay, let's go over some basic concepts, like what if you want to do an if? The if syntax is pretty standard, like if x greater than 0, colon, print x is positive, else print x is negative. So indentation is not optional in Python. Again, contrary to most programming languages, you don't have brackets for starting code blocks like you have in C++, for instance. You don't have AND statements like in MATLAB. So I don't need here an AND statement to close the if. It's very concise in its syntax, but the price to pay is that you need to be strict with your indentation. So if you get the indentation wrong, either you're going to get a runtime error, or the code is going to do something different from what you wanted it to do. So for instance, if I write this is inside the else block. Let's make x negative. So if I execute the script now, it's going to execute both prints because they're both indented. So they're both inside the else block. If I change the indentation, well, it changes nothing because I should have made the variable positive. Sorry. So let's repeat with the variable being positive. So now it only prints x is positive. It doesn't print this because that's inside the else block. But if I change the indentation of that line and I re-execute, I, of course, also get this printed because now this is no longer inside the else block. This is after the else block. So it gets executed regardless of the if condition. So be careful with your indentation. And for that reason, using an IDE is very recommended. Because if you don't use an IDE, you just use a standard text editor, well, all the work for getting the indentation right is on you. And be careful, a tab is not the same thing as four spaces. Those are different things. Okay. So in most IDEs, you can configure your software so that when you hit tab, it actually inserts four spaces or three spaces or two spaces, whatever number of spaces you like. I like four. I think visually it's more clear, but it's not a tab. You can see because when I move through that white space, you can see that I have four spaces. If it was a tab, I would go directly from the beginning to the end of that block. But when I hit a key on my keyboard, I hit the tab. I don't hit four spaces because that would be annoying. Okay, so use an IDE. Visual Studio Code is lightweight, works fine. You have it on every OS. So I would recommend you to use that one. But if you want to use another one, which is specific for Python, like Spider, you can also use Spider. I don't know if there is Spider for Mac, but for sure you have it on Linux. Okay, Boolean values, in case you need a Boolean value in Python, true and false are simply the string true and false with a capital letter. So T must be capital. If you write it with a small t, it's an error. It's not recognized, and you can see it because it doesn't get colored. Or if you want to negate something, you can add a not in front of it. The not is not with the capital letter, though. And it is case sensitive, the language. So of course, capital letters are different from non-capital letters. Strings, we kind of already introduced them because when I started printing stuff, well, the thing that is in between double quotes, it's a string. Funny thing, you can also use single quotes. This is also a string. So you can have strings either with single quotes or with double quotes. They both work the same as long as you're coherent. So if you start the string with a single quote, you should end it with a single quote. You cannot mix them. And it's quite handy to have both options, because if you want to print a double quote symbol inside the string, well, it's much easier if you use the single quote as a delimiter for the beginning and the end of the string. And the other way around, if you want to print a single quote inside the string, you just use a double quote as delimiters. That's the main reason why I think they introduced it both. You can concatenate strings very easily just with a plus. Of course, if you need to concatenate strings inside a print, you can also use the comma. But if you want a variable that is a string, then the comma doesn't work and you need to use the plus. So plus applied to strings is just concatenating them together. It's very easy. Then let's start to do some for loops, which is gonna be very, very useful later. So the syntax for for loops is the following one. So for I in range and then whatever number you want, column, and then you start a new line, add indentation, and then you're inside the for loop. So if I execute the script now, it prints 0, 1, 2, 3, 4. So the standard way of looping is from 0 to the value you specified minus 1. That's kind of the same philosophy of C++, not the same of MATLAB. In MATLAB, typically indexing goes from 1 to n. In C++ and Python, it goes from 0 to n minus 1. And that's going to be the same range we're going to use for when indexing lists or arrays or vectors, whatever. Okay, index go from 0, start from 0. So indexes, so loops are very useful when you want to go through a list. So let's start to see how we can have a list. So let's call the list, I don't know, R. Okay, that's how you make a list in Python. You just use square brackets and commas for separating the items of the list. So now if you want to print all the elements of that list, you can write something like element I equal R of I. Print all the elements of list R. If you want to add an extra new line, you can just do /n. That's the same as in C++, so you should have seen that. So if I execute, I get this output, element 0 equal 2, element 1 equals 6, and so on and so forth. So in this case, I hard-coded the length of the list inside the range. Of course, that's not very practical because in general, you may not know how long a list is. So you typically want this to work for whatever length of R. So we can make this a bit more general by replacing 5 with len R, which is a function for computing the length of a list. So this is gonna run exactly the same, except that if now I make my list shorter, it's gonna adapt to the new length or longer, whatever. If you have two lists, now I can create a second list. And I want to create a concatenation of two lists. That's actually very easy. I can just use the plus operator and I get a concatenation of the two lists. If now I print the list, you can see that the list that gets printed is the concatenation of R and Q. There is another thing that is very similar to a list in Python. It's called a tuple. So let me add a comment. This is a list. I can do the same with a tuple as well. This is a tuple. So tuple and list at the first sight, they look very similar. The only difference is the type of parentheses that you need to use. So for list, you use square brackets. For tuples, you use parentheses. In elements from a tuple, like if I replace R with RT, this code is going to work just the same. So now the elements that are printed are the ones of the tuples, so 2, 4, 12, 65, not the ones of the list. So they may seem like they're exactly the same. They're not. Most of the time we're going to use lists, not tuples, because lists are more flexible. Lists are mutable, so you can change them. You can add elements, you can remove elements, you can replace elements. Tuples are immutable. So once you create a tuple, you cannot do anything to change it. So they're only useful in very specific contexts. But I introduced them to you because you may find tuples being used in some codes that you read. So at least you know what they are. They're just immutable lists. So a tuple is an immutable list. That's all you need to know. We're not going to use them much. Another way in which you can add elements to a list using the function append. So now I just appended an extra element at the end of the list, which is 33. So if I print it now, I get an extra 33 at the very end. And now let's talk about indexing, because that's very important. So when you have a list, if you want to access just one element, well, we saw how you can do it. You just use square brackets and then you use the index counting from 0. What if you want more than one element? Maybe you want the first 3 elements or the last 3 elements. That's gonna happen quite a lot. So let's start to see how that is done. Let's use the list Z. So first 3 elements of Z. First 3 elements of Z, you do 0, colon, 3. And that is called slicing, because you're slicing a piece of this list. So you can see I got the first 3 elements printed. If I want the last 3 elements of that, well, of course, if I know the length of that, I could simply, so in this case, that is 1, 2, 3, 4, 5, 6, 7, 8 elements. So the last one is number 7, and the one before is number 6, and the one before that is number 5. So I should write 5, 8. That is one way of doing that, and it works. So I get 54, 76, 33. But that's not very practical because you need to know the length of the list. So there is a easier way of getting the same result, which is this one. So you count from the end using a minus, a negative index. So if you do -3, it means the third element starting from the end and counting backward. So that should give me exactly the same elements printed. Yeah. This works even if you want to print a single value. Like if you do -1, it's the last one. Okay. So 0 is the first one, 1 is the second one, -1 is the last one. -2 is the one before the last one. Okay, so if you use negative indexes, you're basically counting backward from the end of the list. The same is going to work also for arrays. When we do math, linear algebra, the same applies there. So this is very, very useful. We're going to use that quite a lot. And that is quite typical of Python. So in other languages, the syntax is quite different. So I think you need to get used to that. Yeah.
Thank you for the next number much larger, and maybe I go out with the starts on the beginning.
I've never tried, to be honest, but I think you get an error. Like if I do -13. Oh, okay. It saturates. It saturates. I thought it would give you an error, but no. Yeah, a problem that you have with Python and with these like interpreted languages is that they try to avoid giving you an error if they can, which means that sometimes it's hard to spot your own mistakes. Because in this case, I would have rather to get an error, because of course what I did was wrong. But instead of giving me an error, the interpreter figured out a way to interpret my command as something meaningful, and it gave me an answer, which was probably not what I wanted to get. And so it's up to me to figure out the mistake. That's a downside of interpreted languages. Of course, as in all languages, instead of doing a for loop, you could also do a while loop. I mean, the syntax is pretty standard. Basically, here I'm doing something that's very similar to what I did before with the for, but I'm doing it with a while just to show you the syntax of while. It's nothing special. So let's move on to functions. Functions are going to be very useful for us. To define a function, you use the keyword def, the name of the function, and then list of input arguments, colon, and indentation, as usual in Python. So this is a very silly function that simply sums three numbers that are taken as input. And then if you want to call the function, well, the syntax here is the usual one. So if I sum 2 plus 3 plus 4, I get 9. Okay, a few specific things of functions in Python. You can have default values. Like for instance, I could say that the third argument is optional. And if it's not specified, the default value is 0. And in this case, I can also call f specifying only two input arguments. And the third one is going to take the default value 0. Okay, so the same function that sums 3 values can also be used for computing the sum of 2 values. Something a bit more interesting is that, especially when you have functions with many values, it might be useful to use argument naming. So in this case, it's not going to be really clear. So let me change how this function works. Okay, let's say that the function computes a minus b plus c, so that the role of the different argument is not the same. And now, instead of simply specifying the values in this standard way, I can add the name of the arguments. And if I do that, of course, nothing is going to change. But if I flip them, so if for some reason I want to specify first B and then A, I can do that in this way. And of course, the result that I get are different. Even if the order of the value is the same, I get 2, 3, 4. But now A is taking the value 3 and B is taking the value 2 because I specified so. So this becomes very useful when you have like default values for all the input arguments and you only want to specify maybe the last one without specifying the values for all the previous ones. You can do that using this trick of using the name of the input argument to which you want to assign a value. You can have functions that return multiple values. Like if you want to compute these two computation and you want to return both of them, you can do it, for instance, in this way. You can just put together the two values in a tuple and return the tuple. It could also be a list. It's just the tuples are very often used in this context. That's why I'm using a tuple. It works even without the tuple. You can just put them separated by a comma and it works. You can have as many as you want. It's very flexible. And then besides function, another key element that we're going to use are classes. So if you don't know what a class is, that's a bit of a pickle, but I'm going to try to explain you real quick. Who doesn't know what a class is? Okay, everybody knows what a class is. Who does know what a class is? Should all raise your hand, otherwise there's a problem. Okay, there are some people who haven't raised their hand in both times, so I don't know what to do with you guys. Okay, as a punishment, I'm not going to explain what a class is. So next time you're going to raise your hand if you don't know it. So to define a class, you just use the keyword class. So let's suppose that I want to create a class for representing a 2D point. The key element that you typically want to define when you create a class is the constructor. And Python has a very weird syntax for defining the constructor, which is the following one. So it's a function that goes inside the class. So as all functions needs the keyword def. And then the name of the constructor is underscore underscore init underscore underscore. It's very ugly. I don't like it, but well, we have to deal with that. Another very peculiar thing of Python, all the methods of a class, including the constructor, need to take as first argument self. So if you're familiar with C++, basically self is the same thing as this in C++. So it's a pointer to the object on which this method has been called. It's just that in C++ that's hidden, so you don't need to write it in every method. In Python, I think for historical reason, because initially it was developed as being like a procedural programming language, so without classes, and then classes have been added later on. They had to patch it, and so they had to explicitly write down the pointer to the objects as this self keyword. So it's a bit ugly. It's a bit of an extra work that's required every time you need to write a class, but we have to deal with that. So in this case, a point to the object would take as input the two coordinates of the point. And then the constructor, as usual, it should just store the values that are passed to it. So for storing the values, you do something like that typically. Store the values taken as input arguments. And then we can add another method, which we can call I don't know, print point, which is simply a method that prints the value of this point. And we can have another method like increment x, which increments by 1 the coordinate x. This is very stupid stuff just to show you the syntax. Or another one, like compute norm. This 2 times symbol, that's the way you do powers in Python. So if you want to compute something to the power of 2, you use that syntax there. For computing the square root, you need to use a function from the library math. So that's why I wrote math.sqrt. Problem is, Visual Studio Code is telling me math is not defined because I forgot to import the library math. I can fix that by adding import math. So the import is like include in C++, same thing. But here it's very flexible. So instead of having the import at the beginning of the file, you can have it anywhere you want. It's very weird. You can also have it inside the function itself. So that library math is imported only if you execute that function. If you don't execute that function, that library is not imported. So if you have an import error, it's going to be triggered only when you call that function. It's not going to be triggered at the beginning of the script. So the key thing that you need to remember is that when you have a class and this class has some internal variables, to access those variables, you need to use the self keyword followed by a dot and then the name of the variable. Okay, and it only works inside the methods of the class, of course, the self keyword. And you need to specify it as the first input argument of each method of the class. Again, ugly syntax, but that's what we have. So since we are working with, we started working with a bit with the imports. No, change my mind. Let's first see how you use the class, because now we just created the class, but we didn't use it. So let me create an object of this class. And then I can use it. So I'm gonna create a point with coordinates 4 and 5. I'm gonna print it. Then I'm gonna increment the x coordinate. I'm gonna print it again. And then I'm gonna compute its norm and print it. Okay, so first I get 4, 5, which were the initial values for the coordinates. Then it becomes 5, 5, because I incremented x by 1. And then I get the norm of this, which is square root of 50. So could be that number. Now coming back to the import. This is one way of importing a library and using a function from that library. There are different ways. So let me show you the other ways. You can do from math import sqrt. And then if you do that, you don't need to specify that that function is from the library math when you use it. You just use it as if it was defined in this file. So if you're using that function a lot, I think it's easier if you just import its name so that it's easier to call it. There is also another way which is not recommended, which is from math import star. And then you just use everything you want from that library. You can see that Visual Studio Code, okay, this is too much even for Python. So these methods exist, but not inside the class. So if I want to use wildcard import, so importing everything from a library, I can do it, but it needs to be outside a function or a class definition. This way is not recommended because you might have clashes without realizing it. So maybe you have two functions with the same name defined in two different libraries. And if you import with the time symbol, then you don't see that you have overlapping of names. And so one of the function is going to be overwritten by the other one. You don't realize it. So you maybe have a mistake in your code and it takes ages to find it. So it's better to avoid this kind of import. The other two are fine. You just import the library, but maintaining the name, or import a specific function from that library. These are the golden standard. Okay, let's see quickly a bit about NumPy. We have 10 minutes. We don't need to see everything because NumPy, we're going to use it a lot. So I can also introduce you little by little during the lab sessions. Typically, the way we work with NumPy is that we do import NumPy as NP, which is yet another way to import in a library. You import the library, but you give it an alias, which is typically just a shorter name, which makes it a bit faster to use it. And typically the short name for NumPy is NP. And now, after you have imported NumPy, you can use all the classes and all the functions inside NumPy doing np dot. So for instance, if you want to create an array, you can do x equal np dot array, and you specify the values inside that array. So NumPy arrays may look a lot like list. Even the syntax to specify them is quite similar. Basically here I specified a list and then I passed it to the function np.array to transform this list into an array. The main difference is that NumPy arrays are done for doing algebraic computation, whereas Python lists are not. Like if you're summing two Python lists, you are concatenating them together. You're not summing them. when you're summing two NumPy arrays, you're getting a summation, not a concatenation. Like for instance, here, if I create another NumPy array with different values, do that. So this is the array X, this is the array Y. If I sum them, I get really the summation. So 3 plus 1 equal 4, 6 plus 2 equal 8, 9 plus 6, 15. If I did the same using list, I would get the concatenation of the two lists, which is not what I wanted here. So for doing math, we need to use NumPy. We cannot just use Python list. But apart from that, they work in a very similar way. So if you want to access an element of the array, the syntax is the same that we have seen for list. If you want to do slicing, you can do negative indexing to start from the end going backward. Everything works the same for accessing elements. So if you want to figure out the length of an array, however, you cannot use len as we did for list. You need to use shape. The shape of X is X.shape. So shape gives you a tuple, because in general, arrays could have multiple dimensions. So indeed, arrays are not only used for representing vectors, but they also used for representing matrices or tensors of any dimension. Okay, so you can add as many dimensions as you want. You're not limited to two-dimension matrices. So that's why you have a tuple. Of course, in this case, since X is actually a vector, the tuple contains only one value, which is 3. So if you want really the value, because for instance, you want to do a for loop over that, like for I in range, you cannot do that. You cannot do for I in range of X.shape. At least I hope you cannot do that. Yeah, you cannot do that. It gives you an error. So what you should do is X.shape of 0, because of the tuple, you take the first element, and that is the value 3 that you want to use for looping. So this should fix it. Yeah, it worked. You have the transpose operator, X transpose, which is simply dot capital T. It's very handy. So if you print the transpose, well, actually in this case, you don't see any difference, because when you print it, it gets printed as a line. But mathematically, it's going to be treated as a different object, because it's no longer a column, but it's going to be a row vector. It's very practical to create vectors without specifying their values. When I say vector, actually you should think of array, because that's a real name. So sometimes I mix the math terminology with the NumPy terminology. So if you want to create an array containing all zeros, you do np.zeros, and then you can specify the size. You can also create a matrix by specifying a size which is a tuple. So Small a is just a three-dimensional vector containing zeros, whereas capital A is a 3 by 3 matrix full of zeros. The same thing, you could also do it using ones instead of zeros. So there is another function called ones, which does exactly the same, but populates the arrays with ones instead of zeros. Of course, if you don't want ones, but you want 5 as standard, you just multiply times 5, and then they're all gonna be filled with 5. Because when you multiply an array times a scalar, you're multiplying all the elements of the array times that scalar. Okay. Okay, I think we're running out of time, seeing people fleeing, so I think we can stop here for today. I'll see you on Friday. I think we can stop here the NumPy tutorial. We're gonna come back to it when we start the lab sessions. Please make sure you install all the software on your machine as soon as possible, so we have time to fixing problems in case you encounter them. Okay. On Friday, it's going to be standard lesson. So theory, you don't need to have your own laptop. See you on Friday.